Hey guys, just doing a quick video on index laws. So these index laws should largely be revision because they're year 8, year 9 and year 10 material from previous years. These laws allow you to simplify expressions that involve certain base numbers and their indices. So in the following examples, we're going to have A and B representing bases, and M and N are integer indices, integers being whole numbers. So these index laws are, starting from the beginning, multiplication. We have two different base numbers with indices. The solution or the simplification is the same base number, but you've added the indices together. So the answer to this is going to be the same base number, x to the power of 6 plus 3, which is going to be x to the power of 9. The next law involves when you're dividing, same base numbers but different indices, or any indices really, they don't have to be different. The answer is going to be the same base number but the indices subtracted. Now remember, in subtraction the order is important, so it's that top index minus the bottom one. So a to the power of m take n. So here we have the base number of 3, and then the top power is x minus 2. Because we can't actually work out what x minus 2 is, that is where we leave it. Okay, we've performed the simplification using the index law. Next one here, if you have a base number to a power raised to a power again, then you multiply the power inside with the power outside. So this looks like it's not anything to do with this question because you don't have a base number to a power, but 9 is a base number to a power because 9 is 3 squared, and in this situation it's raised to the power of 4. So all I did was replace 9 with 3 squared. Now we have this situation shown in the index law. So it's going to be the base number 3 to the power of 2 times by 4, which is going to be 3 to the power of 8. I'm just going to leave it at that simplification because that's what I'm trying to show, but you could work out what 3 to the power of 8 is, which is just 3 times by itself 8 times. Here you have another index law. It's the product of two numbers inside, all raised to a power, and what you notice is basically the index law is that that power spreads to both of them, but you're still multiplying the two results there because in algebra, the sign that we don't write is multiplication. So here you have 2x in brackets to the power of 3. That's going to be 2 to the power of 3 times by x to the power of 3. 2 to the power of 3 we know is 8. 2 times 2 times 2 times by x to the power of 3, which we can't work out, so it's going to be 8x to the power of 3. Next law. It's a division in a set of brackets, all raised to a power, and once again, that power spreads to both. So in this situation, you have actually a more complex situation here because the top term, the numerator of that fraction, is a product in itself. It's 3c. So you're actually using the previous index law again, a, b, all to the power of n, to do the top line first, and then you're going to use this law. So we need to deal with the top line first because it's going to be 3c to the power of 4, and then that power of 4 also spreads to the denominator. And then from before, 3 to the power of 4, c to the power of 4, we're dealing with the top, b to the power of 4, 3 to the power of 4. 3 times 3 is 9, times 3 is 27, times 3, 81, times c to the power of 4 over b to the power of 4, and we can't simplify that further. Next, this is a simple one. Any base number raised to the power of 0, as long as the base number is not 0 itself, the answer is always going to be 1. So 4 to the power of 0 is going to be 1. A million to the power of 0 is also going to be 1. Any number to the power of 0 is going to be 1. Here we have 2. The reason we have 2 is that this may be a little more unfamiliar. So negative indices refer to the reciprocal, and the reciprocal is any number, the inverse of any number, which means it's flipped. Okay, if it's expressed as a fraction, it's flipped over. So most of the time when we handle whole numbers, the flipping of that whole number is 1 over that whole number. So this is the most basic example here. 3 to the power of negative 2. In this law, the negative is the reciprocal. That's what's doing the flipping. And then n is the power that both terms in the flipped situation are raised to. So what's happening here? You've got 3. I'm going to write 3 as a fraction, 3 to the power of negative 2. I didn't do anything. All I did was change the whole number 3 to 3 over 1. The negative is going to make the reciprocal of 3. So it's going to be 1 over 3. So all I did was deal with the negative. Now I've still got the power of 2. And just from the previous laws, what you know is that that index spreads to the top, spreads to the bottom. So it's going to be 1 squared, which is 1, and 3 squared, which is 9. So that's an example of using this version of the law, which is if you've just got a whole number as your base. Now I like to show that, but this is the real law that you should be dealing with, because it can handle anything, can handle any fraction here, not just a real number. So really the index law for reciprocals is this. Any number written as a fraction a over b to the power of negative n is actually going to be the reciprocal of that to the power of n of both. So you've got the fraction 2 over 3. The negative is going to find the reciprocal of that, so it's going to be 3 over 2 squared, and that squared is going to spread to both, so it's going to be 3 squared over 2 squared. That's going to be 9 over 4, and that doesn't cancel anymore. We've got another example here, but this is an example of some working out that you might do in a test or your practice exercises. It's combining all of the index laws that we've done so far, possibly into the one question. So what do we have here? 20x cubed all to the power of 6. No, 20 times by x cubed to the power of 6. That's a better way to say it. Divided by 5 times by x squared to the power of 7. Now, the first thing I'm going to do is deal with these numbers. 20 over 5 is 4. Okay, I can just work that out. So this is actually 4 times by x cubed 6 over x squared to the 7. So I can focus on the index laws here to do with x. So it's going to be 4 lots of x cubed to the power of 6. Well, the index law says that you multiply the indices, so 3 times by 6 over x 2 times by 7. It's going to be 4 lots of x to the 18 over x to the 14, which is equal to 4 times by. Now you've got a division of the same base number with different indices, so you're going to subtract the indices. 18 take 14 is equal to x to the 4th. So in algebra we don't write the multiplication sign, so it's going to be 4x to the 4. Alright, so that is a video on the index laws. Hopefully that helps you out, and I'll see you in the next one.